Chapter 8, the Costs of Taxation. As I told you in the last chapter, this is an application of Chapter 7, Welfare Analysis, where we will be using the tools of consumer surplus and producer surplus to analyze the impact of taxation on market participants. So things we'll cover here are, let's see, how does a tax affect consumer surplus, producer surplus, and total surplus? What is deadweight loss of a tax? And we've actually already talked about deadweight loss, but we'll see it here again. What factors determine the size of deadweight loss? How does tax revenue depend on the size of a tax? And actually, there's an additional concept we'll be talking about. So 3 additional concepts, which some of them were listed there, that I'll focus on, other than just using the tools of welfare analysis. I'll call them out here, and then we'll address them each one by one. But it doesn't take too long. I will say that they are subtle and they are kind of challenging for this particular chapter. After we cover the main concept of welfare analysis of taxation, these 3 additional concepts are what end up separating my students, like my A students from my B students from my C students. But I'll call them out now. 1 is the relationship between deadweight loss and elasticity. 2 is the relationship between deadweight loss and tax size. And 3 is the relationship between tax revenue and tax size. We'll come back to that. I just wanted to list them there so that you can write them down and keep an eye out for it. Okay, so a tax, we already know that it drives a wedge between the buyer price and the seller price, right? The amount that buyers pay at the counter and the amount that sellers end up keeping at the end. It raises the price for the buyer and it lowers the effective amount that the seller gets to keep. So we learned that all in Chapter 6. It also reduces the quantity that's exchanged. We go from Q star to what I think last time I called it Q tax. And so we learned also that it doesn't matter who you tax, whether you tax the buyer or the seller, that it still has an impact on the market that would be the same regardless of who you tax. Okay, so remember taxes, we have supply and demand. The market without a tax would be an equilibrium, PE and QE, or what I like to use, P star and Q star. And then when we impose a tax of, say, $T, it creates a tax wedge, right? It creates this wedge between the buyer price and the seller price. Buyer ends up paying this higher price where this tax wedge touches the demand curve here. And then the seller ends up keeping this lower amount, right? The difference between what the buyer pays and what the seller keeps, of course, that distance is the tax. So let's use this to impose now these tools that we've just picked up, the tools of welfare analysis, so that we can apply them to this concept of taxation. Last thing I forgot to point out here is that we learned in Chapter 6 that the quantity exchanged is an equilibrium. It is quantity supplied equals quantity demanded. It's just lower than we would have been without the tax. So that should make sense, that taxation discourages transactions, right? Because again, buyers pay more than an equilibrium and sellers keep less than they would in equilibrium. All right, so let's now use the tools of welfare analysis to analyze taxes. Let's draw the tax outcome here by hand. So on the left, I'm going to draw the graph, and on the right, I'm going to actually build a table. And this table is actually going to be very useful for analyzing the welfare impacts, the well-being impacts to market participants. And I'm going to use a bunch of letters, is what I like to call alphabet soup. So for the next few chapters, this chapter and the next one, we're going to use a lot of A, B, C, D, E, F, whatever, and you're going to kind of get tired of it, but it's going to prove to be very useful in analyzing market impacts of either government policies or just the impacts of just well-being in general, even if there's no one impacting the market. And so let's start again. This is taxation. So taxes, right? Imposing these tools, the tool of welfare analysis, consumer surplus, producer surplus, and total surplus. And so let's model the market. We have our negatively sloped demand curve, and we have our positively sloped supply curve. Kind of losing my voice, as you can tell. So there's Q star, equilibrium quantity, And then equilibrium price is here. Okay. That's under the free market outcome, assuming the government does not intervene. But suppose the government does intervene. It creates this tax wedge, and we've already learned that it does not matter who you tax, so we're not even going to shift the supply curve or the demand curve. And here is the supply price. And then up here we have the buyer price, also known as the demand price. I'll use a B for buyer, okay, and S for seller. And at these prices, we know by now that the equilibrium quantity with the tax, that it's QT, right? So we do have quantity supplied equals quantity demanded here. It's just lower, okay? And so we're going to use, once again, the tools of welfare analysis, or of consumer surplus, producer surplus, and total surplus, to analyze the impact of taxes on the market. And to do that, I'm just going to fill in these with letters. Put an A, a B, a C, D, E, and F. I know those are the only letters that I need, but if I were to overlabel like G, H, I, it's okay as long as I know the definitions of these concepts, as long as I know what consumer surplus is, what producer surplus is, like what the definitions are, the concepts. As long as I understand them, it doesn't matter if I overlabel. If I underlabel regions, like if I omitted the F, then that's a problem. So don't be worried about overlabeling. Underlabeling would be an issue. Okay, so let me set up that table that I was talking about. We're going to ask ourselves, what's consumer surplus? What's producer surplus? We'll also ask, what's tax revenue to the government? Because if you impose a tax, there's going to be tax revenue. And then what's total surplus in the end? Under two different situations. Under the free market situation, meaning there's no tax, free market, free of government intervention. So in other words, we're right there. That's the free market outcome. And then under the case when there's a tax, so with tax, and then looking at the net change. Okay, so remember the definitions. Consumer surplus is the difference between, actually I'll write it up here. Consumer surplus is the difference between what buyers are willing to pay and what they actually pay. And we know that willingness to pay is represented by the demand curve. And producer surplus, again from chapter 6, is what producers get, that's the price that they sell the good for, minus their cost of production. So producer surplus is the difference between price and the supply curve, because the supply curve represents costs. And so if we ask ourselves, hey, first of all, under the free market outcome, what's consumer surplus? Well, they're getting Q star units, and the price is P star, and here's willingness to pay up until Q star units. Therefore, consumer surplus is what? A, B, and C, right? The difference between the demand curve and price up until the amount of units that they end up buying. So A, B, and C. Again, here's willingness to pay, and here's price, and they're exchanging, or they're buying Q star units. Therefore, the difference between willingness to pay and price is consumer surplus. Similarly, producer surplus is the difference between price and the cost of production up until the amount of units that they sell. Well, they sell Q star units under the free market outcome. Therefore, the difference between price and cost up until Q star is D, E, and F. Tax revenue. What is tax revenue from this market if it's the free market outcome, meaning there is no government intervention? Well, that means there is no tax. That means there is no tax revenue. Therefore, total surplus is this whole triangle here. Right? Remember the difference between willingness to pay and cost, because these prices cancel out. In other words, the difference between demand and supply up until the amount of units that they exchange. And so we end up getting, just like the table predicts here, A, B, C, D, E, and F. A, B, C, D, and F. Yeah, that's right. The whole region there. So that is the outcome under the free market situation. But now if the government imposes a tax, the buyer's now paying a higher price. The buyer's paying PB and only buying QT. So consumer surplus, if this is the price and this is the willingness to pay, consumer surplus ends up shrinking to just region A. So consumers lost B and they lost C, just like we talked about in chapter 6 when we looked at what happens when the price increases, and we said they lose this region here. B, they lose because those units that they would still buy are a higher price. C, we lose because they're not purchasing the units between here and here. Okay, so we've talked about this before. We're just imposing the tools we learned in chapter 7 to the tax concepts we learned about in chapter 6. So consumer surplus under the free market, ABC, with a tax, they pay PB, so they only have A. Therefore, the net change is minus B minus C that they lose in welfare and good, in better offedness, right, and well-being. Because remember what these concepts are measuring. They're measuring the benefits to market participants, okay, from the existence of the market. All right, producer surplus, same definition, right? The difference between price and cost is just the case that now price is here, cost is here, and they're only selling QT units, so they drop down to F. And so producers lost D and they lost E. The government, tax revenue, they do have revenue because we're imposing a tax of that red wedge, right? That's the tax wedge. That's the size of the tax from here to here. And these are the amount of units being taxed. Therefore, if we're going to compute tax revenue, it's the amount of the tax times the amount of units that get taxed. So we end up getting that tax revenue is B and D. Right? Tax revenue ends up being this area in here. Okay. So that's B and D. Before the tax, the government didn't have any money from this market. Okay. So they ended up gaining B. And so now we can look at total surplus with the tax. We can just go down this way. Oh, I forgot to write the D. D, don't forget this. That D right there. So again, tax revenue for the government is the size of the tax times the amount of units being taxed, and therefore it's this area in here, which is B and D. Okay, and so the government gained, not just B, I'm sorry about that, the government gained D also. Okay. All right, so the government gained B and D because it had nothing from this market, right? So I could have tax from other markets, sure, but I'm saying from this market, the existence of this market. So total surplus with the tax, we can just add these up on the table. We have what? A, B, D, F. Graphically, it's this region here, A, B, D, F, right? That's the total surplus from the existence of the market. A goes to consumers, B, D goes to the government, F goes to producers. And so if we look at the net change, we can go from here to here and see what happens, or we can see here what's left over from this. I personally like to go this way. It doesn't matter. You can model what goes from here to here and see what's the impact, what's the minus, and what's the plus. I personally like going down this column here instead, just because as long as you did it right, you'll be able to see the net change. So for example, the B that was lost by consumers, which is this region here, was redistributed to the government. That ends up being a wash, right? It's still surplus. The tax revenue is still surplus because society gets it in the form of merry-go-rounds or road infrastructure or national defense. So it's no longer going to the buyer, but it's still going to society as a benefit from the existence of the market. It's just in the form of merry-go-rounds from a government-funded park, for example. And so that was just a redistribution. It came from consumers and it went to the government. C, no one recovered C. So we still have minus C survive, right? This C right here. Minus D, what producers lost, that was recovered by the government. Again, in the form of merry-go-rounds, for example. So that ends up being a wash. It's a redistribution of well-being, right? Of welfare, of goodness or benefits from the existence of the market. But E, this loss of E, no one picked it up. So we end up getting minus C minus E. And that region right there is this part here, if you can see my green. No one picked up C. No one recovered C and E. We lost this welfare here. And this region, C and E, is what we call that dead weight loss that I described before. Dead weight loss is loss in total surplus, usually from the government intervening in the market. So if they impose a policy that takes us away from this equilibrium, then we necessarily will shrink the economic pie. Remember the last time, or maybe the time before, we already talked about that. If you deviate to the left, total surplus shrinks. That was last week, actually, or last chapter. If you deviate to the right, total surplus shrinks. Right? So dead weight loss is that loss in surplus. So this right here is dead weight loss. So what do we learn? We learn that taxes lead to inefficiency because we lose surplus in the market. Okay. And the effects on it affects both consumers and producers, right? Consumers lose B and C, producers lose D and E, and then part of that ends up being recovered by society as a whole in the form of government revenue. All right, so this is the welfare impact of taxation on this particular market. So make sure you're able to model this. On MindTap and on the exam, you might have numbers here. This is, I don't know, a 20, and maybe that's a 40, and this is a 32. I'm making stuff up, right? So now maybe I ask you, hey, quantify the new producer surplus with the tax. So you'd have to find the area of F. You can do that, right? The area of F, that height is what, 20, because it's 40 minus 20. And then this distance is what? 32. And so F would be what? 1/2 times the base times the height. Right? So you can compute these things. There's so many questions that can be asked of you here. What is consumer surplus without a tax? Find the value of ABC. Of course, you would need to know all these numbers, but sure, I can put the number, sure, and then I could say compute it. Right? Or what is the loss in consumer surplus? So you'd have to find the area of B and the area of C and add those together, and then that's the loss in consumer surplus from the existence of the tax. Or what is the impact to the government? That's plus B and plus D, so measure that area. Right? There's so many questions that can be asked of you here. But be prepared to analyze this. And again, this is simply an application of two concepts we've already learned about: taxation and welfare analysis. I do want to point something out that I didn't focus on too much when we talked about the tax material in Chapter 6, is that taxes are used for two things. One is because the government needs money, right? The government, it's basically the income to the government. Two, it's to alter market outcomes. Because, for example, if this is the cigarette market, Q star is too high in terms of, what we believe to be good for our people and our society, because smoking causes lung cancer, so we may not want a lot of smoking out there, right? Both because it harms individual people, but also because there's like secondhand smoke effects. So then if the government wants to discourage behavior, it can tax. So again, there's two reasons why governments tax. One is they want to raise money, they need money. Two is they want to alter behavior, right? They want to discourage people from consuming too much of this particular good, for example. So then if you want to do number two, you go straight into that market. You go tax cigarettes, you go tax alcohol, if that's what you want to. If you want to alter behavior, you go directly to the market. But if you want to tax because you need money, you might want to be a little strategic in which markets you tax. And that's what brings us to the first of our 3 additional concepts that we'll be layering in here. And so these 3 concepts, let me list them here, that you need to make sure you understand, are the relationship between deadweight loss and elasticity, sensitivity. 2, the relationship between deadweight loss and the size of the tax. And 3, the relationship between tax revenue, how much the government raises from the tax, and the tax size. the size of the tax. By the way, this will give us something known as the Laffer curve. So it's related to the Laffer curve. We'll come back to the Laffer curve pretty soon. Okay, so let's start with this one. The relationship between deadweight loss and elasticity. So here we go. Deadweight loss and elasticity. So how market sensitivity affects deadweight loss. And so what we're going to do is we're going to show two markets that have basically only one difference between them. And what it'll be, it's going to be the difference in relative elasticity. Okay? And elasticity, basically. And so I'm going to try to draw either the supply curve or the demand curve identical in both of them. And whichever one I choose to hold identical, that means that the other one is what's going to be different between the two plots. So for example, suppose I hold supply the same. So meaning I want to try to draw it the same slope, same intercept. And I think that's pretty much the same slope with the same intercept, right? Pretty close. And one of the plots, I'm going to make it more elastic. And it can't be on the supply side because supply is the same. So if I want to make it more elastic, it's going to be on the demand side. And so if I draw the demand curve for, say, the one on the left, let's say the demand curve looks like this. And then for the other one, it looks like this. And I asked you, hey, which market is more elastic, more sensitive? There's only one difference between them. The supply curves are the same. The difference is the demand curve. And you should be able to answer this question right now. Which curve, demand curve, is more elastic? Is it the one on the left that's steeper? Or is it the one on the right that's flatter? By now, you should be able to identify that the one on the right is more elastic. It is more sensitive to price changes because it's closer to being that vertical line. And remember, when you get the vertical line, you can make that E for elastic, perfectly elastic. I mean vertical, I meant horizontal, horizontal line. And the one on the left, demand curve, is closer to being that vertical line now. And that's the perfectly inelastic one because you can make that I. Remember that? So that's how you can tell. Remember, the steeper, the more inelastic, the flatter, the more elastic. And if I impose a tax here, here it is, from here to here, here's the deadweight loss of that tax. Right? That's the deadweight loss of the tax. If I take that very same tax and I move it over here and try to make it fit perfectly, there it is. So it's the very same tax. I literally grabbed it and put it over here. And let me just fill this one back in here. So make sure it's, make sure it's the same size. Right? So the reason I grabbed it was just to make sure it's the same size. Oh, that looks like that's not it. Looks like it's here. Okay. And look at what happens. I impose the very same tax size on the more elastic market, right? This one's relatively more elastic than this one. This one's relatively more inelastic because, again, the supply curves are the same, but the demand curve is steeper on the left than it is on the right. The flatter it is, the more elastic, which is on the right. And look at what happens to deadweight loss. It's bigger. This should make sense. It should make sense that the market that is more elastic, more sensitive to price changes, and this is a price change. Taxes are a price distortion. The market that is more sensitive should respond more, right? Here we have Q star, and look at the response in terms of quantity. It dropped by that much. Versus the market that is relatively less elastic, or more inelastic, same thing. It didn't respond by as much, right? Because it's less sensitive to price changes. So that's what I want you to understand here, that if you impose a tax, depending on which market you impose it on, it could lead to bigger deadweight loss or smaller deadweight loss. If the market is more sensitive to price changes, the deadweight loss is going to be bigger. If the market is less sensitive to price changes, the deadweight loss is going to be smaller. So if you're raising taxes because you need money, you're the government and you need money, this should be something you consider, right? If you're raising taxes to alter behavior, then you just go straight to that market, the soda tax, right? But if you're raising money because you, the government, need money, sorry, if you're raising taxes because you, the government, need income, money, then you might want to be strategic, right? You'd probably want to, at least I would if I were a policy advisor, advise that they tax the market on the left over the market on the right, because the market on the left has a smaller negative impact on participants, smaller deadweight loss, in other words, versus the market on the right has a bigger deadweight loss. So that's one thing I want to make sure you understand. By the way, this can be done with, instead of holding that supply curve fixed, I could have held demand fixed and then varied the supply curve. So in other words, I'm just going to draw it quickly here. I could have just held demand to kind of have the same intercept and the same slope. And then for the other one, have supply be flatter here and steeper here, and then do the same thing. Use the same size of a tax under both of them and see which one gives you the bigger deadweight loss. You should already be able to think about sensitivity and say, hey, the market that has a flatter supply curve is going to give us a greater deadweight loss. Why? Because it's more sensitive to price changes. All right, on to the next one. So we just covered deadweight loss and elasticity. Now let's talk about deadweight loss and tax size. Okay, deadweight loss and size of the tax size. So listen to that. We just finished talking about deadweight loss and elasticity. Now we're going to talk about deadweight loss and the size of the tax. So how the size of a tax impacts deadweight loss. And so here's our market. We're in equilibrium. And we initially impose a tax of T, right? And we know that our equilibrium quantity with this tax, our QT as we've called it before, would be Q1. And our deadweight loss would be this region in here, right? There's our deadweight loss. And then now let's say we double the size of the tax. So literally twice that red wedge. So that's twice the size. Look at what happens to the deadweight loss. The deadweight loss is more than twice as big. You can tell because look, you still have this little orange region, plus you can draw another little orange region right here. If I draw a line right here, that's another whole other orange region, and then we have this extra part up here. So deadweight loss, when we double the size of the tax, deadweight loss more than doubles. It increases by more than proportional to what we did to the size of the tax. And let's do it again. This time let's triple the size of that wedge. So here's a tripling of the size. If you want to pull out your ruler, you can, but that's 3 times as big as that original tax size. And look at the deadweight loss with that. This is our deadweight loss. And you can put for sure 3 little orange triangles in there and then some. The deadweight loss, the red one or pink, whatever color you want to call that, is more than 3 times as big as the original deadweight loss, the orange one. So when we triple the size of the tax, we more than triple the deadweight loss. That is an important relationship to understand. That tripling or changing the size of the tax will impact the deadweight loss by more than whatever increase you did to the tax. And that relationship we can plot on this graph here. If we were to put tax size here, the size of the tax, and the deadweight loss, we shouldn't have like a straight line here like that, because that would mean that tax size and deadweight loss increases proportionally to tax size. But it doesn't. It increases by more than proportional. So if we increase our tax, the slope of this, the rise in the deadweight loss, is actually increasing at an increasing rate, right? So the slope is getting steeper in this case, right? So when we impose a tax, we need to think about the implications on deadweight loss. That the bigger that tax gets, that deadweight loss will not only double when you double the size of the tax, it will more than double. Okay, so this is an important thing to take into account, especially if you go out there and start working with government. Some of you will. Some of you are going to go out there and either become politicians or become advisors or work in government offices, whether at the county level, at the city level, federal level, I don't know. Some of you will. This is an important consideration. So that's our second concept. The last one we need to talk about is the effect of tax size on tax revenue. So again, tax size, the length of that red wedge, to tax revenue, the yellow box. So here we have a tax of this size, and we know what tax revenue is. It's the size of the tax times the amount of units being taxed. So we get this yellow region here. And when the tax is small, and let's say we increase the size of the tax, again, do not forget that we're talking about the impact of the size of the tax on tax revenue. So when the tax is small and we increase the size of the tax, look at what happens to tax revenue. Our tax revenue changes to this. Okay? And this reddish orangish box is actually more than before. Right? Before it was the yellow, the full yellow here. And we lost this part when we increased the size of the tax. We lost this part of the yellow, but we gained this and we gained this. And I think we all agree that the gain, this part here and this part here, is more than what we lost. So as we increase the size of the tax, our tax revenue increased. Look at what that says. Again, listen to that. As you increase the size of the tax, you increase the tax size, tax revenue increases. However, we know that consumption of this good, right, the amount of units exchanged drops, right, because this tax is higher. So it further disincentivizes transactions, right, or exchanges from taking place. But again, when initially the tax is small and we increase it, tax revenue ends up going up. The full reddish box is more than the yellow box. But not always. If the tax gets too big, for example, this ridiculous one here, look at what happens to tax revenue. This is now tax revenue. And so we went from this reddish box to this purple box. We lost this part of the old tax revenue. But we gained this little bluish triangle down here and this one up here, or purplish, whatever. We gained this little one up here, we gained this little one. We still have this. This part here is in both of them. So we gained this and we gained this. Add those two up, that's less than what we lost. This rectangular red only part here. So if you make the tax too big, tax revenue can actually start to go down. So again, what did we do? We started with a small tax and we said if you make it bigger, tax revenue will go up. But be careful, if you make it too big, tax revenue will start going down. So that's an important relationship to understand. And that relationship is modeled on what is known as the Laffer curve. Okay? The Laffer curve models, again, the relationship between the tax size and tax revenue. So here we have tax size. Here we have tax revenue. Take a moment to understand or to kind of absorb what it is we're talking about. The impact of tax size on tax revenue. And before we even draw it, or before you even look at your slides, even though you've already seen this in the chapter, think about what we just modeled. We showed that at small taxes, that tax revenue can actually increase if we increase the size of the tax. But if we make the tax too big, tax revenue starts to drop. And so we can model this relationship using the Laffer curve, and it looks like this. It intersects here. Why? Because if you don't have a tax at all, tax size is 0, you're not going to have any tax revenue. And basically, as you get, say you're here, you have a small tax. And so that means here's the tax revenue, right there, right, this level. And if you increase the tax size, then that means tax revenue goes up. At these smaller levels, as you increase tax size, tax revenue goes up. At some point, it hits a maximal point, and so that would be here at this tax size. If you make the tax size too big, tax revenue starts to drop. So again, this is modeling the relationship between tax size and tax revenue. This curve is actually a really interesting curve. The reason it's so interesting is because we actually don't really know where we are on the Laffer curve. What we observe in a particular point in time is a particular tax size and the corresponding tax revenue. That's all we observe. We don't observe the full curve. So for example, So again, we have tax size and tax revenue up here. And suppose in a particular year we observe, in other words, the data tells us that, this is our tax size and our tax revenue, our corresponding tax revenue right here. So for this tax size, and here's the tax revenue we're collecting. Okay. And that's all we observe. We don't observe, the full distribution here. We just observe that particular point. And the thing about it is, some people might argue, hey, lower taxes. Other people might argue, hey, increase taxes in order to increase tax revenue. Again, I may say increase taxes to increase tax revenue, and you may say, no, decrease taxes, because then that's how you increase tax revenue. And we don't know where we are. It is possible that the curve actually looks like this. Oh man, I missed it. So when I miss a curve or a dot and they don't match, I invoke what I call the big dot theorem. And the big dot theorem solves a lot of problems. And so the Laffer curve, maybe it looks like this. And so when I say, hey, lower taxes, because if you lower taxes, you're going to increase tax revenue. That's true, right? If you lower taxes, we'd be going in that direction. So then I'd be right if the blue curve were the right curve. But maybe that's not the right curve. Maybe where we really are is actually we're on this curve. Whoa, we're really here on this curve. Oh man, I missed it again. So now we invoke an even bigger dot. Maybe we're on the black curve. Maybe that's the true Laffer curve. So if you lower taxes like I suggest, that actually would lower tax revenue, right? So if we wanted to increase tax revenue and we're on the black Laffer curve, we should actually increase taxes to increase tax revenue, right? And so this is what's so interesting about it, is we actually do not know where we are until after we impose a policy change and then we observe what happened to tax revenue. And so during Ronald Reagan's presidency, this is what is known as supply side economics, also known as Reaganomics. They really argued that they believed we were on the blue one. They were arguing, saying, let's lower taxes, because if we lower taxes, it's going to increase tax revenue. They thought we were on the right-hand side of the Laffer curve. And after this ended up happening, turns out we weren't there. Right? So again, we don't know where we are until we impose a change and then we observe what ended up happening. That's why the Laffer curve is pretty fascinating. It's not no laughing matter, like I say. And if you Google right now, Laffer curve and excuse me, an award, you'll find some controversy there that's been happening, not about the economic theory, but just about the guy who identified this curve and whether or not he should be getting a particular award. Anyway, that's a different story. But again, this is a concept I want to make sure you understand, right? The relationship between deadweight loss and, not deadweight loss and tax size, I'm sorry, tax revenue and tax size. And this is basically chapter 8. We're essentially done. You're responsible for reading everything, and I'm assuming that you have. Hopefully this makes sense. I know it does. So if it got a little tricky, just rewind and sit through it again. We'll move on to chapter 9.